Okay, for this question, a curve C has equation x squared plus 4xy minus y squared plus 20 is equal to 0. Show that at stationary point on C, x is equal to minus 2y. Okay, find the coordinates of the stationary points on C and determine their nature by considering the value of d2y over dx squared at the stationary points. The first part of this question carries 3 marks, and the second part here carries 8 marks. Okay, let's begin by differentiating using implicit differentiation. So we're going to differentiate this. Therefore, d dx into x squared plus 4xy minus y squared plus 20 is equal to 0. Now, if we do differentiate this, we're differentiating the 0 as well. Okay, differentiating x squared, you're going to end up with 2x. For 4x, this is a product rule, so we have 4x times the derivative of y, which is 4x times dy by dx. So that's going to be plus 4x times dy by dx. Also, y times the derivative of 4x, so y times 4. That's going to be plus 4y. Differentiating y to the square, you're going to get 2y dy by dx. And of course, if you differentiate 20, you're going to get 0. And if you differentiate 0, you're going to get 0. So this is equal to 0. And from here, we can factor out dy by dx, 4x minus 2y. So we have then dy by dx, and I've got 4x minus 2y is equal to, the 2x can be set on the other side as well as the 4y. That's going to become minus 2x minus 4y. Okay, now dy by dx can equal to minus 2x minus 4y divided by 4x minus 2y. We can equate that to 0 because at the stationary point it's going to be dy by dx equal to 0. So from here, okay, we can eliminate this and we have minus 2x minus 4y is equal to 0. So minus 2x minus 4y is equal to 0, which ends up as minus 2x is equal to 4y, and x can be equal to minus 2y. So this has been shown, because we were told to show that x is equal to minus 2y here and here. Okay, now where do we go from here if we want to find the coordinates of the stationary point? So what we can do is we can substitute x minus 2y into the equation of the curve. Okay, so let us do that. Substitute x equal to minus 2y in x squared plus 4xy minus y squared plus 20 is equal to 0. X squared, so x is minus 2y, so minus 2y to the square plus 4 times x, x is minus 2y times y minus y squared plus 20 is equal to 0. That's going to become 4y to the square minus 8y to the square minus y to the square, and you can descend the 20 on the side, minus 20. So 4 minus 8 is minus 5, minus 5 minus is not okay, 4 minus 8 is minus 4, minus 4 minus y is minus 5, so minus 5y squared is going to equal to minus 20, giving us y as being plus or minus square root of 4. That's going to become plus or minus 2. Now that's the y coordinate of the stationary points. What about the x coordinate? So x is going to be equal to minus 2y. So when y is equal to 2, x will equal to minus 2 times 2. So minus 2 times 2 is minus 4. Similarly, when y is equal to minus 2, x will equal to minus 2 times minus 2, which is then 4. I may call this, if you want, a as being minus 4 and then 2, and then I can have b as being 4 and minus 2. So these are the coordinates of the stationary points. For the second part, in the question we have been told to determine their nature by considering the value of d2y over dx squared. This is what we need to find at the stationary points. To determine their nature, what we're going to do, we're going to look at the second derivative. When we differentiated this, we came up with this, right? So let me just write all this down here nicely. So I got then 2x, call this second part if you want, plus 4x dy by dx, alright, minus 2y dy by dx, and then plus 4y is equal to 0. Now let us see how we can proceed. Maybe I can, there's 4, 2, 4, 2, 4, so all of that can be divided by 2 on both sides. So if we divide by 2 on both sides, we're going to end up with x plus 2x dy by dx minus 2y, no sorry, minus y, because if you divide by 2, minus y dy by dx, and then plus 2y is equal to 0. So if we differentiate, so let us differentiating. Okay, differentiating this, you differentiate x, you're going to end up with 1. This is a product rule. Okay, so we can take 2x multiplied by the derivative of dy by dx, which is d2y over dx squared. So then I've got 2x times d2y over dx squared, plus, now you take this times the derivative of that. So dy by dx times 2, so plus 2 dy by dx, okay, minus, we can take y times the derivative of dy by dx, product rule again, so minus in brackets if you want, y times d2y over dx squared. Then you're going to take this dy by dx times the derivative of y, so plus the derivative of y is dy by dx, so dy by dx times dy by dx is going to be called dy by dx to the square, plus 2y, 2y. So you differentiate this, you're going to get 2 dy by dx. Yeah, right, is equal to 0. Now, what do we know? We know that, let us take at this point here, if we're fine with this, or maybe we can try to simplify 1 plus 2x d2y over dx squared, okay, plus 2 dy by dx minus y d2y over dx squared, okay, minus dy by dx all squared plus 2 dy by dx is equal to 0. Right, from here we're going to take minus 4, 2, so x minus 4, y is equal to 2. So 1 plus 2 times x is minus 4, so 2 times this is going to be minus 8 d2y over dx squared, plus 2 dy by dx. dy by dx is basically at that, I would say, let us say at minus 4 and 2. We know that dy by dx is going to be 0, so 2 times 0, minus d2y over dx squared times y, and we know that y is going to be equal to 2, so 2 times d2y over dx squared. dy by dx, okay, that's going to be 0 at that point, so 0 to the square minus 0 to the square, plus 2 times 0 again, 2 dy by dx. So this can be simplified as 4 dy by dx is equal to 0. So 1, you can see, you can send the 1 on the other side, it's going to become minus 1, minus 8, and then minus 2 is minus 10 d2y over dx squared, and that's going to give us d2y over dx squared as 1 over 10. That's a positive value. So at a positive value, we have a minimum point. This is d2y over dx squared is greater than 0, so that's minimum point. And I'm sure you can have a guess, but we don't want to take any risk. So let's move on and do it nicely. I've got 4 and then minus 2. This time, at that point, I've got 1 plus 2x. 2 times 4 is 8. So 8 d2y over dx squared. Alright, plus 0. Okay, minus y, and y is 2. So minus minus 2. That's going to become plus anyway. d2y over dx squared. And that is 0. That is 0 is equal to 0. Now, let's do the algebra. You can send the 1 on the other side, and you got minus 1. So 8 minus minus 2 is 8 plus 2, which is 10. d2y over dx squared. That means d2y over dx squared is equal to minus 1 over 10 at that point. Minus 1 over 10 is basically less than 0. Therefore, at that point, we have a maximum. So this is the nature of these, of their points. Okay. So here we are for this question. All right. Okay. Take care. Nicely done here.